Good evening, everyone. In this video, I'm going to explain machine learning techniques lab experimentally regression analysis. In this experiment, I perform three machine learning techniques in Python: simple linear regression, multiple linear regression, and logistic regression. And the first one is simple linear regression. In this, I have read CSV data file into pandas data frame. In this step, I loaded the dataset using pandas. The dataset is stored in CSV file in a CSV file, and I converted it into a pandas data frame so that we can easily perform analysis and machine learning operations. And and the second one is data cleaning step. We have to find the missing values and replace it with mean. In real data sets, some values may be missing. To handle this problem, we perform data cleaning. First, we identify missing values and then we replace them with the mean value of the respective column. This technique is called mean imputation. And the third one is selecting independent and dependent variables, choosing X and Y. In regression, we predict one variable using another variable. The variable used for prediction is called the independent variable X, and the variable being predicted is called the dependent variable Y. And the fourth one is we have calculated the regression coefficients, complete B0 and B1. In linear regression, we calculate two parameters, slope and intercept. The slope tells how much y changes when x increases. And the intercept tells where the regression lines crosses the y-axis. And the fifth question is calculate the predicted values. The formula is y predict is equal to b0 plus b1x. After calculating the regression equation, we use it to predict y values based on the x values. And the sixth one is we have calculated the sum of squared error value. Formula is SSC is equal to summation of y minus y predict the whole square. SSC measures the total error between the actual value and the predicted value. And the smaller SSC means the model predicts closer to the real data. And the seventh one is root mean squared error. The formula is root RMSC is equal to square root of summation of y minus y predict the whole square divided by n. RMSC measures the average prediction error of the model. Lower RMSC indicates better prediction performance. And the eighth question is calculate R square coefficient of determination. The formula is R square is equal to 1 minus SSC divided by SST. R square indicates how well the regression model fits the data, and R square value closest to 1 means the model explains data better. And the ninth question is plot regression line visualization. Blue dots indicates the actual data and the red line indicates a regression line. This graph visually shows a relationship between x and y. The regression line represents a predicted trend in the data set. And the 10th one is predict a new value, predict y for a new y, new x. Finally, we use a regression equation to predict the y for a new value of x. And the next one is multiple linear regression. First, we have to read the data set. Same as before, we loaded the data set using pandas. And I have used the iris regression.csv data set. And the second one is data cleaning process. We remove missing values using mean imputation. And the third one is choosing variables, independent variables. X1 is a sepal length cm, X2 is a sepal width cm. Dependent variables, y is equal to petal length cm. And then the fourth one is calculate coefficients. The formula is y is equal to b naught plus b1 x1 plus b2 x2. And the fifth one is calculate predicted values. Formula is y predict is equal to b naught plus b1 x1 plus b2 x2. And the sixth one is calculate SSC, sum of squared errors. And the final result is 70.94. And the seventh one is calculate the root mean squared error. And the final result is 0.687. And the eighth one is calculate R square. Final result is 0.847. This shows a better performance than simple regression. And the ninth one is predict a new value. Given x1 is equal to 10.5 and x2 is equal to 0.6. Predicted value y is equal to 15.25. And the next one is logistic regression. We have load the data set, load data using data set using pandas. And the second one is data pre-processing. Steps performed in this includes handle missing values, converts categorical values to numeric using label encoding, and the data type is int. And the third one is choose variables, independent variables, sepal length cm, sepal width cm, dependent variables, species. And the fourth one is cost function and gradient descent. Steps performed include normalize the data, add bias term, apply sigmoid function. Sigmoid formula is sigma of z is equal to 1 by 1 plus e power minus z. And then update weights using gradient descent. And the result final cost value is minus 2.22. And the fifth one is plot cost versus iterations. We plotted a graph showing x-axis iterations and y-axis cost. This shows how the model improves during training. And then sixth one is finally, we have calculated the accuracy. Formula is accuracy is equal to correct predictions by total predictions. And the result accuracy is equal to 0.66. And finally, the logistic regression is used for classification problems. In this experiment, I trained the model using gradient descent and evaluated the performance using accuracy. Thank you.